Find the derivative of g of x equals the secant of x times cosine of 3x. So g of x here is a trig function, the secant, of an entire expression which itself is a product of x times cosine of 3x, which hints at how to take the derivative. We're going to start with the outermost function, that's the secant. Take the derivative of that, leave the inside alone, and then the derivative of the inside for the chain rule. And the inside is a product, so we have to use the product rule. So our derivative, g prime of x, will start with the derivative of secant. Well, the derivative of secant is secant tangent, leaving the inside alone. So secant of x cos 3x, tangent of the same x cos 3x. And now we multiply by the derivative of the inside of the original trig. That's this. The derivative of the inside to complete the chain rule. Well, the derivative of that is a product of x times cosine 3x. So we will have the derivative of the first, that's a 1, times the second left alone, that's a cosine 3x, plus the first left alone, that's an x, times the derivative of the second. Well, the derivative of cosine is negative sine of 3x, and then times 3 to complete its chain rule. So g prime of x will equal secant x cosine of 3x tangent of x cosine 3x, and then in the square brackets we will have 1 times cosine 3x will just be a cosine 3x. And for this next one we have a negative and a 3. There's the constants. We'll put those to the front. Negative 3. There is an x, and there is a sine of 3x. Now it's customary to write the power functions and the smaller trig functions first. So technically what's in the square brackets is maybe the smaller trig functions. They're not as big as the secant and the tangent are. So those may be moved out front. I'll just turn it into parentheses now, but it's cosine 3x minus 3x sine 3x, all times the secant of x cosine of 3x and the tangent of x cosine 3x. And there's our derivative, g prime of x.